All right. If you go to 36, I'm just going to briefly use that to get you started. So at this point, you know a lot about angles, you know a lot about triangles, right? You know what needs to, the tools that are available to you. Alternate interior, angles, we brought that into this unit, okay? So I just wanted to take a moment again. These are some, I would say, instead of steps, I'd call these like tips, right? That could help you. For sure, always sketch your interpretation of the problem and label everything. I would say fill it up, right? Fill up diagram, because usually if you are given angles, you can actually add several additional angles to it. Okay? Additionally, okay, identify the unknown angles, right? Like what are unknown angles or sides that you will need to calculate? Assign a variable to it. Put an x, a y, all different variables, okay? Fill in all the angles, right? You can use sum of triangles equal to 180, alternate interior, subtraction of angles, anything like that, supplementary, complementary, all of that goes, okay? And that will help you out. If the height and altitude is provided, you'll be working with right triangles. I think that goes without saying. Check if the information you transferred makes sense. Is it in the correct place? Okay, I'll say this. If the marks of a question, if there's 4 marks associated with a word problem, it's probably not just going to be like, oh, pair, solve the side across, I'm done, right? You're going to have to be, maybe my triangle that I just have drawn is too easy to solve. Go back and check, am I reading it right? Where is the angle, right? Is this correct? Next up, set up and solve, and round to 2 decimals. I would say final answer, that is for the final answer, and include units if at all possible, okay? So here are some examples that I can, I'm just going to show you some examples, right? You've got the one where you've got angles of depression, okay? When you have angles of depression, you're going to be somewhere up, right, and looking down. Now, the problem is, where do I put the angles? Sometimes the question is going to tell you that wherever you're up, right, you're going to be somewhere in between the 2 points that you're looking at. So one is to the left, one is to the right. Okay, that's the assumption. Somewhere in between, right? What if you have 2 angles of depressions, but you're both you're looking from the same location? We did a hot air balloon question like this, okay? So you're looking at 2 distinct points. Just make sure you start. I'm going to use a different color here. You should probably do that too. Green maybe. That's what I'm going to do. That they're measured. I'm going to do a different color than green because I already have green there. Make up your mind. Make up your mind already. Okay. There's that horizontal, right? Always measured with respect to the horizontal. I will also write that here, horizontal. Okay. So that is important for angle depression. Horizontal, right? You're in between. I'll write this down, in between the 2 sides here from the same point. You're not looking to the left or to the right. You're looking from the same point towards the same direction. Okay? I'm just trying to help you out here to envision. So in terms of angle of depression, this is about it, right there. I mean, I'm not saying these are all the cases you're going to see, but this is something that you should definitely always consider. Have this in mind. And we can use alternate interior to bring things into our triangle. And if the height is provided, sometimes that throws students off. They have this here. But remember, yes, you can work with the right triangles, but you can also work with a big triangle that is there, okay? So that's something you should definitely keep in mind. One key is to probably solve for a slant if at all possible. That's probably one way to go. Let's keep going. 37. Angles of elevation. Okay, you've got a few more scenarios there. So remember, there's your horizontal again, and you're measuring the angles from the horizontal looking up. Right, there it is again. So two of these scenarios, right? You're looking up, like maybe two people are looking up, or maybe two wires are attached to the ground at a certain angle of elevation. Right? That's the scenario. This wouldn't be the wires, right? This would just be people looking up because it's something hovering up there. A plane, a bird, a kite, you name it. Then you've got an antenna, right, that has supporting wires. That's another scenario. And keep in mind, folks, if these angles aren't the same, you can't just assume that this is going to be perfectly halfway in between. You cannot, okay? And 99% of the time, it's not going to be an isosceles triangle. Then you've got these scenarios. These ones are a bit tougher, to be honest. But maybe let's fill this in a little bit. Okay. I will put a little word problem under here. You are 35 yards closer. Okay, that's if you see something like somebody starts off and walks 35 yards towards something and then looks up again, you've got this scenario here, okay? And the key here is going to be what? I'm going to use a red pen to fill in. So far, this triangle right here has the most info. If this is 30, then we know this is 150, right? Using supplementary angles. So now you've got that. 150 and 25. That's the 175, which means this must be 5 degrees here. So it's like a ripple effect. Okay, once you find this, you can find that, and now you have your pair. Okay, you can use sine law for this. And my suggestion would be solve for the mutual side. Okay, solve for shared side. That's what I would recommend. So you start here, solve for this one, and then you can move into this right triangle here if you'd like. And then you have to be careful. What is it asking me for? Is it asking direct distance from the second location to the top? Is it asking for direct distance from the beginning, the first position to the top? What is it asking for? Is it asking for the height of the structure? You name it, right? So that's that. This is where you move. You walk closer, okay? Then there's this one where you just look up, okay? So I will label this one looking up or tilting up, okay? So you start off with, you're looking at the bottom of something. Maybe you're looking at the Statue of Liberty. You're visiting a majestic statue, and you're looking at the bottom, you're looking at the top, like, wow, right? So that's what's happening here. This is 20, right? Let's say it's 20 degrees angle of elevation to the bottom, and then it's 50-degree angle of elevation to the top. So from these two pieces, you should be able to make up this piece right here. From here to there, you just go 50 minus 20, right? You get the 30 here. So you just go 50 minus 20 to get that angle right there. So you have to be careful not to mix them up, not to think, oh, 50, this is 50 here. It's 50 from the bottom all the way to the top, to the this line looking up, right? And look at all the variables I've assigned, right? M, X, Y, Z, right? I have variables everywhere. You don't need to do that. Just do the ones that you think you're going to solve for. And then, of course, I could ask how high is that actual, like how tall is the actual structure you're looking at? how tall is a sine, all of those things. That's where this one would come in handy. Okay, that's strategy. So if you want to have this on your study sheet, if you think this is going to help you, have a little version of this in there, especially I would say these two here, and maybe even the two angles of depression scenarios. Okay, those are probably good ones to have on your study sheet. I'm going to ask here, is there any question you would like me to? Okay, so I know that some of you may have needed a bit more time, but I don't have that luxury right now. So it took us a while, right, to get there. And that's okay. Word problems are a bit trickier. So please grab a marker or a pen and make corrections. If you need to like draw, at the very least, draw the correct diagram on the side and write down the correct answer so you can like go from it and work backwards, okay? So for the first one, please have a ruler. That it makes them just so much neater and easier to fill in, okay? You can even use the edge of your calculator. I don't really mind as long as you have it drawn. So in this case, there's a telephone pole that's supported by two wires, and they're on either side. So it's kind of telling you that the pole is somewhere in between, right? They have angles of elevation of 30 and 60 respectively, 35 and 60. They're 15 feet apart. They're anchored 15 feet apart. So where they're attached to the ground, that distance is 15 feet apart. And they're connected at the same height along the pole. So that's also important, right? That they're on the same height, or else we would have a different situation happening here. Sketch it first. So I'm just going to sketch this. And technically, the pole isn't perfectly in the middle, right? It's probably more offset a little bit if you think about it. It's probably somewhere there. And you've got the 35 degree is here. And the 60, I don't care if you made it look like a isosceles triangle, but I'm just letting you know it's not, right? This is probably more like it. This is steeper than that one, right? So angle of elevation from the horizontal going up, right? That's how we measured. And we know that this is 15 feet. And that's from end to end. So don't be assigning it to one of the right triangles. We know that the pole is at a 90. So we're assuming that it's 90 on either side. And it's attached to the same height. So the pole could be taller, but we know that they're attached to the same height. If they hadn't been, this would be a different scenario, right? Like it would be probably make it a bit more complicated. Okay, so if you have everything where it goes, you get a mark. Where it's supposed to go, you get a mark. And sometimes it's also good to have letters on it, but and this right now, if you just have that, you get a mark. I would say if you made a mistake at all, -1. Okay, you just lose that mark today. B, what's the height of each wire? So one thing you need to make sure is the 15 is the whole side, so it's that big triangle. So you almost have to ignore the pole for a little bit and just figure out what this is. This is 85 degrees, okay, which is across the 15. So it's sine of 85 over 15, and that'll be sine of, let's say 60, and then you just call this x, right? You may have called it something else. I don't really care. As long as the one that has 60 degrees, if that answer matches yours, then we're good, okay? So it'll be 15 times sine of 60 divided by sine of 85. X is going to be 13.04 feet. So I would give you 2 marks for the first one. So 1 mark and 1 mark for the correct final answer. Then we'll do this all over again. So this is the first wire. Then it's sine of 85 over 15. Then it's sine of 35 over, let's call this y. I just want to say something. Now, technically, you had SAS at your disposal as well. Side, angle, side. So if you wanted to use cosine law to solve for y, that was available to you as well. So y is 15 times sine of 35 divided by sine of 85. You can see that. There we go. Y is equal to 8.64. And we expected that to be shorter because it's across a smaller angle. In fact, it is the shortest side, and that's what we would want. So I would just give you a mark for basically doing this whole thing again. Okay? So 3 marks there for that. C, determine the height at which the wires are connected to the pole. Basically the height of that triangle. So you can call that H. You can grab any of the slants. I'm going to grab side X, and I'm going to go sine times sine of 35. So height there would be 13.04 times sine of 35. And that is 7.48. I believe you get the same answer using this side. Anybody use this side and got the same answer? Joel's shake. Yeah, yeah. He's on. Okay. Confirmation. I need confirmation every once in a while. So we've got in total 1, 2, 3, 4, 5 marks for this page. Okay. 5 marks associated. So put a mark out of 5 on this. Then the back side. So D hiked to his favorite spot while he was out scouting. I do hunt, so I do scout. There is from the cliff, right? There's some geese at an angle of depression of 50 degrees. Then about 100 yards behind the geese, right? About 100 yards behind the geese, there's some there are beavers. And the beavers are at an angle of depression of 30 degrees. Both are located to the right side of where he's standing. So I'm even being more specific, right? Like I'm looking out and I'm not just turning to my, right? Like it's like I'm looking down to the same spot. Okay, so here's the diagram. So you've got to make sure you get this right. 2 marks for this part. So assume this is the cliff and this is me, right? So we can call that D. And there's a marsh or pond or something like that. So we're looking down, and there's the geese at an angle depression of 50. Okay, so I need to make sure I introduce the horizontal up there, right? It's not there, right? Like you have to introduce it. Okay, so this right here is 50 degrees, right? Then 100 yards behind the geese, there are the beavers, okay? And that is an angle of depression. So first of all, the 100 yards go here. And then this is the key here. I'm looking towards the beavers, and I kind of crossed over the 50, but the 30 is measured from the horizontal to that line where I look to the beavers. So that's what's happening here. So don't squeeze it all into this corner. You may wander out, right, and just fill it in there. So if you have all of this, you've got 2 marks. So I would say if you have the 100 here, you get a mark for that. But I would say if you got this wrong at all, I would say -1. Because that's like everything hinges on you getting this one right. Everything. Because if you don't get that right, but we're still going to give you the marks for the work, okay? But you're going to lose a mark for this. That means that this is 20 degrees. Because 50 minus 30, so that little wedge there is 20 degrees. Okay? So let's solve now. Calculate the distance, the direct distance between Mr. D and the geese. So this is what we're wondering. I'm going to put an X here, and letting my audience know that that's what I'm going to solve for. Conveniently have a pair. Okay, so sine of 20 degrees over 100 yards. And what would I want now? I would want, if I want to solve for this side, I would need this angle here, which I do have, right? If you think of this as your transversal, that 30 will just conveniently be parked in there. And in fact, this 50 will conveniently be parked in there. You're going to stop me, right? It's in here. That's alternate interior, right? So if that's, not that we need this right now, but I'm filling it in anyway. So if this is 50, then this is 130. 130 and 30 is 160, plus 20 is 180, so that confirms that we're doing things right. So again, this is my pair. So sine of 20 over 100 yards, then I'm going to go sine of 30, this angle, over x. X is going to be 100 times sine of 30 divided by sine of 20. We're not solving for angles. We haven't been solving for angles in a while, so please don't forget how to do that. You got to use the inverse for that, right? And what is the answer for this? I get 146.19. Is that correct? Yeah. So naturally, if you put the angles in the wrong place, you lose a mark under the diagram, but I would give you full marks for doing this correctly if you use the right numbers. So I would have to check, is this supposed to be, what is this supposed to be based on your mistake? So let's say you put it in the wrong and you get something like a 50. If it's supposed to be 50, then you still get the step mark, like for that step. Okay? So that's where I have to check and make sure you know what you're doing. At least copy the diagram down, at the very least. Okay? That's B, so 2 marks for that. That's basically setup and solving. C, using the cosine law. So I'm forcing you. Cosine law, calculate the direct distance between Mr. D to the beaver. So we want this distance right here. Look up, make sure you know which one I'm talking about. So Y or G, lowercase g, it's okay. Cosine law, I can use cosine law now because I have. So if you want for C, just briefly, let's copy down that triangle. I would encourage some of you to do this as well, to sketch what you have, right, and get rid of all that busyness there. This is 146.19. This is 100. So there you have your SAS. Now I can solve for y. So you would go y squared is equal to 146.19 squared plus 100 squared minus 2 times 146. So as long as you're using the number you solved for earlier, you're going to get full marks for this part if you did this right. Okay? So a mark already for correct substitution, cosine law is done properly. Then we type all of that in, we get 37,625.28 something, and that gives us 193.97. No, sorry, I'm on the wrong. Sorry, guys. Mr. Dirksen, you're messing everything up. That's the wrong line. I was looking at a different question. Sorry, guys. Get your act together. 50,000. Is that better? Yeah, is that gooder? Like I used to have a student joke about it, and I'm like, were you joking or were you serious? Right? 2, 2, 3. And this is the longer side here in this operation, so it makes sense, right, that it should be 223. What's the height of the cliff Mr. D is standing on? Oof, I ran out of space here, but I think I can make it work. I'm going to use this triangle right here to help me out with that. So this is H. So real quick, just sketch it here. I hope you can see that. I'm just going to call this H. I'm going to call, this is 50. This is 90 here. I do know this one, 146.19. So it's basically 146.19 times sine of 50. If you don't know what I'm doing right now, if you're like, Mr. Dirksen, I forgot the formula. This is your pair, correct? Make up your pair, and then sine of 50 over H. You solve as you would normal sine law, right? H is 146.19 times sine of 50. Okay, that is, hold on. 111, so 111.99 yards. Is that what we're getting? Rounding? Maybe rounding is off. If you did it using a different law or a different side, maybe you use this side right here. Could I have used this right triangle here? Yes, that's a big right triangle, and you use y times sine of 30, it would also give you the height. If your answer is off because of that, don't worry about it. In fact, rounding is the least of my problems today, or least of your problems as well. We don't worry about that today. 1 mark there, and 2 marks for the cosine law before. Sorry, I forgot to mention it. So 1 for correct substitution, 1 for correct final answer. We didn't do 3. If you did do 3, it's z is 120 degrees. If you did solve for it, it's supposed to be 120. Okay. So how many marks here? 2, 4, 6, 7. 7 marks for the back side. And 5 for the front, right? 7 and 5, 12 total. You're the teacher. I'm not going to argue with you today. Not going to argue. So this is only out of 12, not 14. So make sure you cross that. There was no 6, 7, was there? I got to work on that. Got to revise.
Yesterday, there was 67 days.
Till the end of the semester? Till Christmas, okay.
The second week